Okay, let's continue. Just now we have mentioned in paired t-test, we need to calculate the difference of after and before, and we want to know if the difference is symmetric about 0. That means we need to test if mu d, that means the population mean of difference, equals to 0 or not. So this is the null hypothesis in paired t-test. So here we can find that the step 1 establish the statement of the hypothesis. H0 is mu d equals to 0, and HA is mu d is not equal to 0, and alpha is still 0.05. In step 2, the nu, namely the degree of freedom, equals to n minus 1, and we said that we have 10 numbers of difference, so the sample size should be 10, and nu is equal to 9. And next one, we need to calculate the test statistic, namely t value. And we found that here is a different formula for t value. We find that this part, d bar minus 0. d bar, this means the sample mean of the difference. And here, this part, we can find that this is SD. That means the standard error for difference. SD equals to SD over square root n. This is SD means the standard deviation of difference. So this part is SD over square root n. So how can we get d bar and SD? Let's go back to this part. We said that d bar is the sample mean of the difference. Let's go back to the last slide. This is difference, and there are 10 numbers for difference. So d bar is the mean or the average for these 10 numbers. So do you know how to calculate the d bar? Yes, very good. D bar equals to the summation of all these 10 numbers divided by 10. So that is d bar. But how can we get SD? That is the standard deviation. So how can we do that? I think we have already know how to calculate the standard deviation as. We have learned that in chapter 1. So we already know the formula for standard deviation. This is the formula for standard deviation. So this is the standard deviation of difference. So we can find that we can use this formula to calculate the standard deviation of difference. And this part, d minus d bar. d bar is what we have calculated in the last step here. And what's the meaning of d? That means every number in this 10. So let's clean it. So if we want to use this formula for calculating the SD, you need to use the first number of d is 13 minus d bar and square sum The second number 3 minus d bar square plus -1 minus d bar and square, and so on till to the last number. And we use the summation of all these numbers over n minus 1. And here is 10. But it's not the end. SD equals to the square root of this number. So that is how can we get SD. Okay, so if we have get the number of d bar and SD, and then we can put all the numbers into the t-values formula to get the t-value. For example, in this question, we can find that the t-value is 3.32. So that is the value for t. And the next step is similar with what we did in one sample t-test. This is what we calculated with the data given by the question, and we need to compare this number with a standard t-value. So the standard t-value is this one. Two-sided alpha equals 0.05 and nu equals to n minus 1. And we can get this number from the table A2. Okay, so by checking in the table A2, we found that the standard t-value is 2.26. And what we calculated is bigger than the standard t-value. So that means its corresponding p is less than alpha. So when p is less than alpha, we need to reject H0. So that is the step 3. We make the decision to reject H0. Finally, the calculation is the drug significantly reduced the blood pressure at the level of 0.05 level of significance. So that is the answer to the question of paired t-test. I think the most important thing for you is to distinguish when can we use paired t-test and when can we use one sample t-test and when can we use one sample z-test. Okay, so this is the first method we will learn in today's class. In our textbook, there is determination of a 1 minus alpha confidence interval for the paired mean difference of a normal distribution. But in our class, I won't teach you that part. So you don't need to learn this part. You just know what is the procedure of hypothesis test for paired samples t-test. That is enough. Okay, the second part in today's class in chapter 6 is the two samples t-test for independent means. In the title, we can find that this is also t-test, but this t-test is used for two samples. So it's the same with what happened in paired t-test. Both of these two methods are used for two samples. So that means there will be N1 and N2 in the questions. Maybe someone will think that in the paired t-test, there is only one sample size. There is only one N, right? Okay, so let's go back to the last slide. Here, we said that before is sample 1, after is sample 2. So actually, there is N1 and N2, but in our calculation, we calculate the difference. So we change the 2 sample size into 1. That is the sample size of the difference. So each pair of numbers can get only one number. So we change N1 and N2 into a single sample size N. But actually in the question we have 2 sample size. Okay, so here in this part there are still 2 sample size, N1 and N2, but we don't need to calculate the difference anymore in this part. And we can find that this method is used for independent means. That's very special. That is different from the paired samples. So we said that paired means matched. There will be some special relationship between 2 patients or 2 individuals. For example, they are the twins, or they have the same age and gender, or the 2 numbers are from the same patient, such as before and after taking a special medicine. But here, it's still 2 samples. It's still t-test, but it's not paired or matched. We call it independent. So this method is to be used when 2 independent samples are taken from normal populations for the purpose of comparing their means. So we can find that the purpose for this method is still comparison. So the keywords should be different, right? Okay, so now I will explain what's the meaning of independent. We said that paired sample is based on paired design or matched design. So independent samples is based on completely randomized design. So what's the meaning of completely randomized design? Okay, so here let's think about it. If we have two populations, this is population A and this is population B, they have no relationship. So each individual in population A is independent with everyone in population B. The age or the gender of both of these 2 individuals are different. So maybe one person in population A is a male, 25 years old, but an individual in population B is a female, 60 years old. So they are different. And from these 2 populations, we can randomly draw a sample. So from population A, we draw a sample. We use the little a to represent the sample A. And from population B, we can get sample B. So we can find that all the individuals in sample A is independent with the individuals in sample B. They don't have anything the same. They don't have any properties are the same. So we call it independent. Or we can take another example to explain what's the meaning of independent. Let's clean it. Okay, so here, now I have two drugs A and B. I want to compare the effectiveness of these two drugs. So I need a group of patients to use drug A and another group of patients to use drug B. So how can we design that study? The first one, this is the population of the patient. So I draw a part from the population of the patients, and then I need to divide this group of people into two groups. That is group A and group B. So actually, group A is sample A. Group B is another sample B. So how can we do that? How can we divide the patients into two groups? We can let the patients toast the tail, right? Toast the corn, right? If he had a head, he go into the group A, the sample A. If he got a tail, he go to the sample B, right? So we find that the number one patient, he toast the corn, he got a H. So number one gets into the sample A. Number two gets a tail. So number two gets into the sample B. Number three, number four, both of these two patients, when they toast the corn, both of these two patients all get a head. So number 3 and 4, both of these two patients get into the sample A. So we will find that for each individual, the probability for this person to get into group A or get into group B is the same, right? For example, for number 1 patient, he has 50 to 50% of probability to get into A or B group, right? And for number 2 patients, the probability is the same, 50 to 50. That means he can get into group A and he can get into the group B too. So the probability is 50 to 50. So that means the result of the grouping is random. So here, this study is based on randomly grouped. So we call it completely randomized design. And these two samples, sample A and sample B, is independent sample. We call it independent samples because there is no any relationship between A and B. That is different from the matched design. Let's clean it. Okay, now let's think about what happened in matched design, in pair matched design. We said that, for example, still this patient group, and we need to compare A and B, and we need to divide the patients into two groups, A and B. So for the first patient, we make him toast the corn. If he get a head, he go into the A. If he gets a tail, he goes to the group B. For example, now he got a head, so he go into the group A. But we said that in paired design, these two numbers, these two persons must have some special relationship. For example, they must have the same gender or age. If age can influence our result, can influence the comparison of drug A and drug B, we need these two persons have the same age. If gender can influence the result of the comparison, we need both of these two patients have the same gender. So here, for the number 2 patients, he must have the same gender or age with the first one. And the next key point, that is if A go into the group, if number 1 goes into the group A, number 2 must be in group B. There is no choice for number 2. He have to go into the group B because the paired design is like this. The paired design make the number 2 must go to the group B because the number 1 who is matched with number 2 is in group A. So there is no choice for number 2. He must go to the other group. So for number 1, the probability for number 1 gets into the group A or group B, the probability is the same, also 50% to 50%. But the situation is totally different for number 2 because number 2 must be in different group with number 1. So if number 1 gets into group A, number 2 must be in group B. So for number 2, the probability should be 100% to 0. So we can find that the probability for these two patients are not the same. They are different. So this is the difference between independent sample and paired sample. For independent samples, for each individual, he has the same probability to get into each group. But in paired samples, for one person in the pair, he has the same probability to get into A or B. But for number 2, the probability should be 100% to get into the other group. So that is the difference between these two study design. Okay, so now let's go back to our PPT. So now here is an example. You can read it. Okay. Now let's analyze the information given in the question. So here, the first one, let's read the last sentence of the question. Most often, the last sentence will be the purpose of this study. So here we can find that. What can be said about the underlying mean difference in blood pressure between the two groups? We find the keywords difference. So the purpose of the study is to identify the difference between two groups. So that means we need to use the method of hypothesis test. It's none of business with the estimation. We don't need to calculate the confidence interval. And then we find that between two groups. Oh, this is two groups. Let's go back to the question. Can we find two sample size? Okay, we can read it. Suppose a sample of 8. So this is the first sample size, right? This is N1 and another one. Oh, it's here. A sample of 21. So this is N2. So we can find we have two sample size. So that must be two samples test, right? So for two samples test, we need to use t-test, not z-test, because we said that there is no two samples z-test. There is only one sample z-test. So for the two samples, we need to use t-test. But which method can we choose? Paired t-test or independent t-test? So we need to know if the study is matched or not. Is matched or independent? Okay, so we said that if the question is about paired samples, there will be some keywords such as before and after, or matched, or paired. So can we find those keywords in the question? No, we can't. So if there is no such keywords, that means the question should be independent sample t-test. Okay, so here we know this is a question about two independent samples t-test. So what is the procedure of the independent sample t-test? The procedure should be the same with the other hypothesis test. And we list all the information which is given in the question. This is the sample 1. Its sample size. Its standard deviation. We notice that this standard deviation is the sample standard deviation. So it's S, not sigma. So here, this is the sample mean. And this one is the sample 2. We can get its mean, standard deviation, and sample size. Okay, next one. This is the procedure for the two samples t-test, or we can call it independent samples t-test. So it's still step 1, step 2, step 3, and conclusion. So in step 1, we notice that in the different types of t-test, they have different H0 and different HA. So you just need to remember and to copy it. So here, H0, we have two samples in the question. So we have two underlying population, and we want to know if the two populations are the same. So we use mu1 to represent the first population, and mu2 means the second population. So H0 is mu1 equals to mu2, and HA is mu1 is not equal to mu2. Alpha equals to 0.05. So this is the step 1. Step 2, we need to calculate the degree of freedom. But here, the degree of freedom is very, very special. It's not n-1, because we have two samples here. So actually, nu equals to nu1 plus nu2. So this is the new for sample 1 and this is the new for sample 2. So new 1 equals to n1 minus 1 and new 2 equals to n2 minus 1. So it's still n minus 1, but we can notice that the new equals to n1 plus n2 minus 2. So that is very special. Okay, let's clean it because I have no space. Okay, here, this is the formula for t, but we notice that this t value is difficult to calculate because we can see here this part is the difference of the sample means of the two samples, but this part here is a special one, a special part that is SC. So let's look at this part. So what's the meaning of SC? We can calculate SC with the next formula. So here, N1 is the sample size of sample 1. This is the standard deviation of sample 1. This is sample size of sample 2. This is the standard deviation of sample 2. And this is the same. We can use this formula to calculate SC square. And we can figure it out, the SC. And we put the numbers into the formula for t. And then we can calculate the t value. So this formula, this t value is difficult to calculate. So in our medical statistics, you do need to remember these two formulas. But the rest of formulas you need to remember. Okay, so here, this is the answer. We find that the t value is 0.74, and the next one is the same with the other t-test. We need to compare the absolute value of this number with a standard t-value, and we can get this standard t-value by using alpha and nu, and we can find it in table A2. So in table A2, we find that the standard t-value is 2.052. It's bigger than what we calculated with the data given in the question. So that means P is less than alpha. So we cannot reject H0. So the conclusion is there is no significant difference between the mean blood pressure of the OC and the non-OC user at the 0.05 level of significance. So that is the procedure for the independent t-test, independent samples t-test. Okay, so here, till now, we have learned 3 methods for t-test, but only one for z-test. That is one sample z-test with the given sigma, right? But we have learned 3 methods for t-test. That is one sample t-test when sigma is not given, which is learned in chapter 5, and paired sample t-test used for 2 samples. And 2 samples t-test for independent means, or we can call it independent samples t-test. Both of these 2 is learned in today's class. So till now we have learned 3 methods for t-test. So we can compare the 2 methods and review and summarize the key point in this 3 hypothesis testing method. For example, let's clean it. We said that one sample t-test, that means there will be only one sample size in the question. There is only one little n. And then sigma is not given, but we can use S to replace the unknown sigma. So under these conditions, we can use one sample t-test. And paired sample t-test is used for 2 samples. So we can find 2 sample size. And another one is based on matched design. So it's paired samples. So we can find some keywords, for example, before and after, or paired or matched. If we can find this kind of keywords, we can use paired sample t-test. The last one for t-test is 2 samples t-test for independent means. So it's similar with what happened in paired t-test. We still have 2 sample size, but there is no such keywords like paired, matched, or before and after. So here we said that it's independent samples, and this time we can use independent samples t-test. Okay, so next one, let's do some exercise. You can read it. Okay, so do you know how to solve the question? Let's analyze the information which is given in the question. So as usual, let's read the last sentence of the question first. Is there any difference? Okay, so here, difference, we find the first keyword, difference. That means this question should be a question about hypothesis test, not estimation, right? And next one, between the mean age of these 2 populations, So is there 2 sample size or not? Let's go back to the first sentence. Okay, so this is the first sample size, 125. And next one, here is another one. The mean of 61. So this is sample 1, this is sample 2. We have 2 sample size. So is there any relationship between these 2 samples? Oh, I can say that if the two samples matched or not. No, they are not matched, because we find that there is no keywords in the question, right? There is no before and after. There is no matched or paired. Another thing that is very interesting. So, do you remember that in paired design, we have 2 samples, and 1 and 2, that is the sample size of the 2 samples. So if the two samples are matched. What is the relationship between N1 and N2? Yes, if the two samples are matched, these two numbers of the sample size must be the same, right? Because if there is one person in sample 1, there must be a matched person in sample 2. So we will find that the number of individuals in sample 1 should be equal to the numbers of sample 2. So N1 and N2 must be the same. But in this question, we can find that N1 is 121, N2 is 61. They are not equal. So that means the two samples must independent, not matched. Okay, so here is another question. What is the DF in this question? Now, we already know that the question is about independent samples t-test. So we said that the DF nu equals to nu1 plus nu2. So it equals to n1 plus n2 minus 2. So here is 121 plus 61 minus 2. So it's 180. Okay, so here let's go back to the first question. Is there any difference? So we need to do the hypothesis test. Okay, so let's review the procedure for independent samples t-test. This is what we can know from the question. And step 1. H0 is mu1 equals to mu2. HA is mu1 is not equal to mu2. Alpha equals to 0.05. Step 2. The first one, we calculate the DF. DF is 180. We have explained how can we get that. And next one is to figure out the T. And I have mentioned that the formula is too difficult to figure it out. So you do need to remember the formula. So here, let's just read this number. The T value equals to 41, and we check the standard T value from table A2 with nu equals to 180 and two-sided alpha equals to 0.05. We find that the T is 1.965. So absolutely, this number is bigger than the standard value. So that means its corresponding P is less than alpha. So we need to reject H0. So the conclusion is there is significant difference between the mean age of these two populations of patients at the 0.05 of significance. So that is all for this question. Okay, next one, question 2, exercise 2. You can read it by yourself. You have 1 minute. Okay, I think you have finished. Let's analyze this question. Here, suppose the following are data obtained on 10 men ages 45 to 55. The values are cholesterol readings taken after 12 hours of fasting and repeated 1 hour after eating. test whether fasting significantly reduced the cholesterol readings at the 0.05 level. So we can find the keywords reduce, right? Significantly reduce. That means we need to compare. We need to identify the difference between the two groups. So it's still a question about hypothesis test. Okay, next one, we find that we have two samples. The first one is fasting group, and the second one is after eating. And we notice that for each person, for each subject, he had two numbers. One is from fasting, one is from after eating. So this pair of numbers are matched because both of these two numbers are from the same person. So obviously it's paired samples t-test, right? Okay, so now we know it's a question about paired sample t-test. We need to calculate the difference, right? So here we use fasting minus after eating, and we can get the difference. We notice that some of the numbers are negative and some are positive. And we need to calculate the mean of these difference numbers. We have 10 subjects, so n equals to 10. And we find that the d bar is -3 and SD is 8.56. N equals to 10. And the rest of the thing is just follow the procedure of the paired samples t-test. So step 1, H0 is mu d equals to 0 and HA is mu d is not equal to 0 and alpha is 0.05. Step 2, the first we can calculate the df. df equals to n-1 is 9. And next one, t, we put all the numbers into the formula and then we can get t. In this question, it's a negative number, that is negative 1.11. So we have mentioned that in comparison of this t with the standard t value, we need to use its absolute value. So it's 1.11. And with the help of alpha and nu, we can find that the standard t value is 2.26. So what we have calculated is less than the standard t value. So that means P is bigger than alpha. We cannot reject H0. So the conclusion should be fasting significantly reduce the cholesterol readings at the 0.05 level. Okay, in today's class we have learned two methods for t-test. The first one is paired samples t-test and the second one is the independent samples t-test. So till now we have learned 4 methods for hypothesis test. So after class you can summarize all of these methods. Okay, so that's all for today's class. See you next time.